CompTIA Cloud Plus, Enhanced Identity and Access Management. Let's start out looking at the core application programming interfaces for Amazon Web Services resource access. Realize in this lesson, we're not just going to talk about AWS, we're also going to talk about Azure, which are the two most popular. So our options, first, would be the AWS Software Development Kits, SDKs, and the command line interface. These are going to wrap the underlying RESTful APIs for services like EC2 instances, S3 object storage, Lambda functions, and the DynamoDB very popular NoSQL database. Also, SDKs are available in multiple languages, for example, the popular Python, JavaScript, and Java. And the CLI or command line interface, which can run on Windows 64-bit or Mac OS or Linux, provides command line access to nearly all AWS services. Keep in mind with Amazon Web Services and all of the other cloud providers, anything that's done through what we call the metastructure to the controllers in the data centers has to be digitally signed. They don't all use the same techniques, but they all must be digitally signed. So for example, if you're going to use the AWS CLI, you're going to use the separation of duties principle. In other words, you'll have certain users that'll use the command line interface and other users that'll use the management console. So at AWS, if you're going to give someone programmatic access, as we see here, you're going to send an email to this person. It's going to have an access key ID, which is a pseudo-random username for the secret access key. And the access key will be used by deriving a session key from that key to digitally sign anything done in the CLI. The reason why we have a key derived from that key is so we can have forward secrecy. So what you would do on the 64-bit Windows machine, for example, is you would run command.exe as administrator, then run the command AWS configure. Then you would paste in the access key ID, then paste in the secret access key, choose your default region, so for example Ohio, that way whenever you come into the CLI, you'll automatically be in that region, and then the default output at AWS is JavaScript Object Notation or JSON. Your other options are text or table. Once you set this up, you can make commands by putting in AWS space followed by the service, let's say S3, and then the API call. Then what will happen is a session key will be derived from the secret key, and you'll send the API call through a cryptographic hash similar to SHA-256, and then you'll sign that hash with the session key and then send it up to the cloud. Other core APIs for AWS resource access would be the AWS REST APIs. Each AWS service exposes its own RESTful API through the metastructure, and the requests are authenticated using AWS Signature version 4. Common operations include get, put, post, and delete. And remember, everything has to be digitally signed. There's also the Amazon API Gateway. This acts as a front door for applications to access back-end services. The API Gateway supports REST, HTTP, and WebSocket APIs. In the future, expected to support things like Google's gRPC and GraphQL. The massively scalable API Gateway handles traffic management, authorization, monitoring, and versioning. Here's an example of what it looks like, where you have connected users and streaming dashboards, mobile devices, laptops and pads, IoT devices, and other private applications, all going through the API Gateway, which creates, publishes, maintains, and monitors securely APIs at any scale, billions if necessary. There's an API Gateway cache, which would be a Redis cluster, and then monitoring through Amazon CloudWatch as you manage a wide variety of server-based and serverless platform as a service and software as a service features on the back end. Some of the core APIs for Azure Resource Access would be the Azure Resource Manager REST API. We call that the ARM REST API. This is central to managing Azure resources like virtual machines, storage, networking, and more. It'll support things like get, put, post, delete, and patch, and it requires authentication via the Azure Active Directory, and it uses what's called bearer tokens. There's also Azure SDKs, which could be in languages like .NET, Python, Java, JavaScript, Go, and more. It wraps RESTful APIs for easier integration and error handling. It also has a command line interface, the Azure CLI. A very common tool, one that I used a lot, was Azure PowerShell. It's similar to Azure CLI, but it's tailored for PowerShell environments. It's also useful for Windows-based automation and scripting. After all, this is Microsoft Azure. And then, one of the newer methods is the Microsoft Graph API. Accesses identity-related resources like users, groups, and roles. It's often used in conjunction with Azure AD for governance and access control. Here's an example of a PowerShell script run at Microsoft Azure. Very popular solution at Azure. Keep that in mind for the exam. When you're doing single sign-on and federated access, let's say from your own company, where you're using Active Directory or Open LDAP or Okta or something like that, you'll be using SAML 2.0, the Security Assertion Markup Language. It's an XML-based open-source federation and single sign-on standard. Remember, federation and single sign-on aren't necessarily synonymous. You can have federated access to multiple different services and service providers and not be doing single sign-on. Or you can have single sign-on that gives you access to all of those federated services. SAML 2.0 is used by many cloud SSO connections for thousands of large enterprises, government agencies, and service providers that communicate on the Internet. A key advantage of SAML is its popularity and open source interoperability. Some large companies now require SAML 2.0 for Internet single sign-on. For example, Microsoft 365, Workday, Salesforce, Yammer, and others, including other external ISPs. It's commonly used for federated access to CSPs from on-premises identity providers like Active Directory and Okta. Those are two very popular options. When the iPhone came out, there was a divergence. The app developers that were going to develop apps for the iPhone and others didn't want to do SAML, which was kind of, webby and soapy, right? So it wanted something new involving RESTful APIs, JSON, and other techniques. So that's where OAuth 2 comes in, including OIDC. And often a lot of companies will use both SAML 2.0 for their federated access, but for other mobile devices and pads and specialty devices, IoT and remote users, they'll use this solution, OAuth 2, an open authorization framework that allows the third-party application to get limited access to an HTTP service. OAuth is intended to work with HTTPS, and really it should be TLS 1.2 or higher, and fundamentally allows access tokens to be issued to third-party clients by an authorization server with the approval of the resource owner. The third party then uses the access token to access the protected resources offered by the resource server. Developers use OAuth to publish and interact with protected data in a safe and secure manner. Service provider developers can use OAuth to store protected data and give users secure delegated access. OpenID Connect is a basic identity layer on top of the OAuth 2 protocol. In fact, you can do pseudo-authentication with OAuth 2, but the proper way to deploy this is with OIDC. It verifies the end-user identity using the authorization server. It can get basic profile information about the user with an interoperable REST-like methodology. And OIDC supports web-based, mobile, and JavaScript clients. The protocol is extensible as new functionality is added regularly for IoT, specialty devices, embedded devices, and to work with API gateways. Let's go up to AWS now and talk about identity and access management and kind of get a real-world look at how this operates. Identity and access management at AWS is similar to IAM at Google, where you would actually go up and create your own directory, separate from the one that you're using on premises. Now at Azure, obviously you can have your own separate Azure AD. It's often very common for companies that use Microsoft to migrate some or all of their Active Directory up to Azure. So AWS is kind of interesting. IAM started in 2010, not that long ago. So before that, how did you get access to Amazon Web Services? Well, you used your Amazon account. So you had Amazon.com. You would use that Amazon.com login to get access to AWS. But they created IAM, where you could now have your own directory, where you would have groups, and then the groups would get policies. So the policies are simply just whitelist of JSON. So basically telling you what you can do, right? So you could have up to 10 of these that could be, applied. And they're just basically JSON documents that say, what are you allowed to do? So you would apply this allow list, up to 10 of them, to the group. For example, GRPRO. Then you would create your users, and then you would place the user in the group. And then they would get that particular set of policies, what they could do in the cloud. Now, in the traditional IAM service that you see here and even at Google Cloud, these are persistent access. So anytime I log into the console, I can do this. Now, if we add a user, let's say Sam, before I click on next, notice it's going to be using kind of separation of duties. So do I want Sam to have console access or programmatic access? This is what I was saying earlier. Really, it should be very rare for any user or group to have both programmatic access and console access. So you want to be very careful. So not only I'm going to cancel out of here, are we going to do separation of duties, but we're also going to make sure that when we apply these policies to the groups, that we're using the least privilege principle. We're only giving them the API access that they absolutely need. Now, one of the challenges to this traditional IAM that we've had since 2010 is this is persistent, ubiquitous access to make these types of actions in the cloud. Today, it's more likely you're going to use something at AWS or others like Identity Center. The Identity Center used to be called AWS Single Sign-On. So today what you'll do is you'll go up to the Identity Center and it will give you the ability to connect through federated single sign-on whatever you're using as your own identity provider, like OpenLDAP or Active Directory or Okta or IDRAMP or something like that. So it makes it very easy to set up your federated access or your single sign-on. You just simply connect to your existing identity provider. But it will also allow you to do what we've done since 2010. Create users and groups directly. So in other words, create your own directory up here. But there is a difference. When you use the new Identity Center and you create those groups and users, it's not ubiquitous persistent access. One of the things you have to do is say, when they get a token, what is the lifetime of the token? 15 minutes, 1 hour, 12 hours, 20 hours. So in the new Identity Center, if you create your own directory, they're going to access their resources in a session-based, token-based environment. And that's critical because that actually adheres to what we call zero trust. And in another video that I'm going to make, I'm going to talk about zero trust, which will actually be covered on the Cloud Plus exam. So hopefully I'll see you in that video somewhere down the road.